The following is a discussion between Professor Zhong, known as the founder of artificial intelligence in China, and myself, Eric Werner, one of the founders of distributed artificial intelligence and multi-agent systems in America and Europe. What concerns us particularly are the conceptual foundations of artificial intelligence, and in particular, artificial social intelligence. Professor Zhong starts by looking at agency and its role in intelligence. And I continue in the second half with a discussion of the architecture of the social brain. And this will follow where actually we try to decode the genome that leads to the social brain in order to build future AI models that are not only social, but solve what I call the inference energy barrier. I think you'll enjoy the discussion. For all of those interested in conceptual foundations, I think you'll find it entertaining. Okay, good. It's working, I think, now.
So let's start formally.
Okay, why don't you start and introduce yourself to the international audience. As far as I know, you're one of the founders of artificial intelligence in China. Correct me if I'm wrong. And I'm very honored to be able to discuss these things with you.
Okay. Shall I introduce you to the Chinese audience?
If you want, yes.
Yes. Well, Professor Eric Werner is the senior researcher of Oxford Advanced Research Foundation. He is also the member of International Academy of Information Study. Both Eric and I have the common interest in the research of artificial intelligence. So today we'll have some exchange on the ideas about how to do the research of artificial intelligence. Is that it?
Yes.
Okay.
Yes. My focus today will be on artificial social intelligence.
Yes.
And I know that, how may I ask again how to pronounce your name? Professor Zhong, is that right?
Yes. Yes, okay. Correct. Yes.
Yeah, Professor Zhong and I have some commonalities. It's very interesting because some of the things that he writes have very similar themes than what I have written about. So it's quite fascinating of this common thread that we both have. But I'm sure there are also differences because, you know, we've never really met each other in the past. So we have gone our own way, but it's amazing that we have a striking similarity in some ideas about artificial intelligence, how it works, what the basis should be, etc.
Okay. Shall I start the presentation?
Yes, good.
You will do the first for the presentation?
I think you will be first, yes?
Okay. I will make to present the PPT, okay? Yes. Can you see it clearly?
Yes, clearly.
Okay. The title for my presentation today is the Paradigm Revolution for Emerging Disciplines. This is a law newly discovered. Now, first of all, for the 20 minutes presentation, I will just very few pages of the PPT. Number one is the law of paradigm revolution for emerging discipline. What is the law? To understand the law, we have to look at the following point to understand the law, okay? So the point number one, the paradigm for a scientific discipline is redefined as the scientific worldview together with the associated methodology for that discipline. Right?
Mm-hmm.
Number two, if the properties of the major target of the discipline is radically different from that of traditional ones, the discipline is termed an emergent discipline. For example, subject is radically different from the object. Okay.
Mm-hmm.
Number three, the paradigm for a scientific discipline is the uniquely leading force for the discipline. This is obviously according to the definition, because the paradigm for a scientific discipline is defined as the scientific worldview and the methodology. So they are the leading force for the discipline.
Yeah.
Yeah. Point number four. No problem?
No problem.
Number four. Yes. The paradigm for emergent discipline is unavailable in its initial stage. Do you agree? In the initial stage,
yeah, sure. Why not?
Yes, okay, that's fine. To borrow one paradigm from the traditional discipline is obviously necessary. Okay? Yeah.
So you would say we have to express it in the terms of the old paradigm.
Yeah. So number five, the paradigm borrowed, of course, is seriously mismatched with the emergent discipline.
Yes.
Okay. So the point number six, the mismatched paradigm will lead the emergent discipline research to an unhealthy stage. Mm-hmm. Do you believe?
It could be, but possibly, yes.
Yes, because very serious mismatch between them. Mm-hmm. So the research on the emergent discipline will be something like weird state.
Yes,
right?
Weird
yes.
state. Mm-hmm.
Okay. Number seven, to way out of the unhealthy stage and to enter into the healthy stage, the only solution is to sum up its own paradigm for the emerging discipline and to take over the borrowed one. And this is called paradigm revolution. Mm-hmm. Do you agree?
Well, yeah, the problem is to express the new paradigm first in terms of the attempt to express it in terms of the old conceptual framework doesn't work because it doesn't have the proper vocabulary. So the new paradigm does require a basically new way of looking at things for people to even understand what it's about.
Yeah. So this is why we talk about the paradigm revolution for the emerging discipline, because the old paradigm borrowed from the traditional discipline is not matched with the emerging discipline research. Right. Okay. So this is the meaning and why the paradigm revolution for emerging discipline is valid. Yeah. And the law is valid. Do you agree?
Yeah, I think we don't have to worry about, there is definitely a paradigm shift. I think we should maybe continue to what your particular new paradigm is, because that's what's interesting. Because you
somebody called
a new way
somebody
of thinking.
called the paradigm change or paradigm shift, and so on. Mm-hmm. But because we put up one paradigm and give out another paradigm, so this is really a revolution. The meaning of revolution just the same as the one Thomas Cohen
Yeah,
Right. Yes.
a
Okay.
Kuhn, yeah.
Yes. So there is no problem. And then next page. The paradigm revolution in AI, because AI is emerging discipline. Okay.
Yes,
So this is the application of the law to AI field. Right.
yes,
Now we have the following ideas to present to you. The world is experiencing great change, particularly in scientific research. Right.
yes,
So the physical discipline directed era will be or has been changing to the information discipline directed era. Right?
right. Things are changing
Yes.
very fast.
Yes, very fast, very deep. And
Yes,
then the primary stage of information era also have been changing very fast
yeah,
to its advanced stage, that is intelligence age.
yes. I would call, yeah,
Yes?
the age of
Okay.
intelligence, exactly.
Okay. Very good. Yes. So as a result, the paradigm for physical discipline have to be replaced by the paradigm for information discipline. We use PPD to stand for the paradigm for physical discipline, and use PID to stand for paradigm for information discipline. Okay?
Right. Hmm.
Okay.
So
So,
do you really believe that you can fully replace physics with information science?
pardon?
Do you really believe that you can fully replace physics with information discipline?
Uh, well, this two different discipline,
Right,
so they should have a different paradigm for each of
right.
the discipline. Yes. So I think as an emerging subject, AI is a kind of information discipline,
Yeah,
right? So in the AI research, the borrowed paradigm, which is a PPD, should be replaced by its own paradigm, which is
oh
PID.
yeah, there I agree with you there, yes.
Okay, very good. In somewhat detail,
But
uh,
the reason I agree with you is because I've been reading your book, and so
okay, very good.
I understand you better,
Yes,
what you
thank you
mean.
very much. Thank you.
I'm not sure the audience will understand, but I understand.
Very good. The paradigm replacement in detail can be seen the following 2 points. Right? Okay. Let me use another method. We have passed this one. Now, the PPD should be replaced by PID means that number
Yes,
four,
yes.
number one, the scientific worldview, the mechanical materialism, which is the scientific worldview in the PPD, okay, which must be replaced by the dialectical materialism, which is the scientific worldview for the PID, right?
Uh-huh. Well, yeah, I guess we'll have to, that's very political sounding. But
I will have an explanation later
we
on.
can maybe
Okay.
skip that and go to your information ecology. I find that very interesting.
Okay. And the second one is the methodology. Also have a replacement. That means mechanical reductionism should be replaced by the information ecology.
Yes.
The mechanical reductionism is the methodology for PPD, and information ecology is the methodology for the PID.
Yeah, you
right?
will explain later what you mean by information ecology?
Yes, I will.
Oh,
No
good.
problem.
Because that's
Yes.
one of the
Okay.
central cores of your book.
Yes, you're right. You're right. So more specifically, the scientific worldview for the PPD, it said AI model is artificial brain. Is it? Yes. Many people at the present time think artificial intelligence will have the artificial brain has the model, right? But it is the old or traditional scientific worldview. It's not the information discipline.
Yeah, you will explain that more, and can you explain that now?
Okay. Many people doing like AI based on neural networks.
Right.
The neural network is the brain structure, one of the structure of brain.
Right.
Right. And this is the traditional scientific worldview.
Right.
But in the information, in the scientific worldview of PID, the view is not the same or is completely different. It says AI model should be the information ecological process which is produced by subject-object interaction for realizing subject's goal to seek intelligent action.
Yeah, so, I think this is very central to your theory, because from
yes,
reading your work.
Yes,
and that
this is central point.
Exactly, and there I think you need to explain much more for the audience because they have not read your book, and they will not understand. Like
I have many pages later on.
Good.
Okay.
But make sure you continue because we don't have that much time. So
yes,
this is the central point.
Yes. Next point for the methodology. There is one of methodology for PPD, which is formalization. Therefore, based on formalization, the information used in the GPT and the DeepSeek and the large language model is syntactic information. Syntactic information means formal information. Okay?
Yes, I understand what you mean, but I don't know the audience will understand. But yeah, because normally syntactic may recall different things to them. But I think what you mean, it's a purely formal processing without any, well, continue. I don't want to put words in your mouth.
Later on, I will give a new page to explain each of the concept, okay?
Yes.
So the syntactic information should be replaced by comprehensive information. The comprehensive information is the trinity of syntactic, pragmatic, and semantic information.
Okay, for the sake of your audience and our more international audience, this is where Professor Zhong and I have a very common overlapping vocabulary, and we'll discuss the differences later.
Yes, and later on I would have a further explanation, okay?
Good.
And another methodology for the PPD is so-called divide and conquer. But this methodology cannot be used in the AI research. So divide has been replaced by the law of information conversion and intelligence recreation.
You will explain that later?
Yes. Yes. Okay. let me have a very quick concluding, and then I will explain the further. Okay.
Mhm.
The conclusion number one is the law of paradigm revolution of emerging discipline is evidently valid. Okay, because we have covered the 7 points for supporting the validation of the law, right? And number two of the conclusion, the paradigm revolution in AI is worth of careful consideration.
Oh, yes, definitely.
Yes, but many people didn't consider this. Paradigm revolution in AI means the following 3 points. Okay, AI model should be information ecology process produced by subject and object interaction, rather than artificial brain, rather than neural networks. The second point, the methodology, formalized information should be replaced by comprehensive information.
Do you think that this comprehensive information can be realized in a physical brain?
Yes.
Yes.
In PPT, it cannot produce comprehensive information. Only in PID it is possible.
But I mean, still,
Yes.
can it be realized as a physical system? In other words, an artificial brain.
Yes. Okay, I will show you. Last one is divide and conquer, should be replaced by information conversion and intelligence creation. See, no divide, but conversion and recreation, right? This is a major conclusion. Now, let me give some explanation for much more detail. At this page of the PPT, you can see the paradigm adopted in AI is completely the same as the PPT. The first row and the second row, compare them, you can see AI has followed the paradigm for physical science, not information science. Okay. Well, the red one is a paradigm for information science, which is summed up by ourselves, by our team. Okay. Because of the time, I may unable to explain, to read each of the content for you.
I think, given the time, I think you should focus on the last two, on the ecology and what your contribution is.
Okay. Let me if well, on this page you can see this is an AI model. If we use the scientific worldview of PID, the word statement is what AI studied is information ecology process produced by subject-object interaction for seeking intelligent action for the subject. As you can see from the model, at the input, there's object information reflecting the state of the object in the environment. Okay?
Yeah.
Yeah, but at the output, there's intelligent action, which is needed for the subject. Now, for object information to the intelligent action, the whole process is defined as the information ecological process. Is it clear? Object information, of course, cannot equal to the intelligent action. It should be converted converse to converse, and
Right.
just I said,
It has to be transformed. From
yes,
reading you sound something like Immanuel Kant, the German philosopher, who also has a theory of mind, that there are fundamental categories for understanding the world.
yeah,
Where this difference between the object and the subject, which you
yes,
seem to be going in that direction. Is that correct?
yes, yes. As you can see from the model, the object is at the bottom, and
Right.
this is a subject. Okay, so they are mutual interaction,
Right.
and then I will explain the information ecological process in detail. Next page, right? Form object information through a number of conversion. That
Right.
is information
Yes,
ecological
exactly. I
process.
think there you're getting at some of the core, namely
Yes,
these transformations that have to occur and this additional information that has to occur in order to have intelligence. Yes.
yes, yes. And even more detail, see the next page. Now, the objective information first experience the perception and then produce perceptual information. Okay,
Right.
that is comprehensive information. It has syntactic, semantic, and pragmatic information, three components, right? And then further, cognition. That means cognition. The output of cognition will be knowledge, okay? And then the third one is called strategy making, right?
Mm-hmm.
Based on the knowledge to convert the perceptual information to the strategy
Right.
under the control of the G, that means the goal, under the guidance of the goal.
Right.
And then you can produce the strategy at this point.
Right.
And then next point is execution, right?
Right.
Execution means the strategy will
Yes.
become action.
Right.
Intelligent strategy becomes intelligent action. So the information ecological process, including the conversion from object information to the perceptual information, and then from perceptual information to the knowledge, that is information conversion.
What I thought, if I may, what I thought was interesting too is where you said in your book that the very perception is guided by the goal, right? So
yes,
that the goal is already influencing the first part, because the very perception is already guided by the goal. Very interesting.
Yes, this is a very important point, because P, G, K means problem they want to solve. G means the goal for the problem solving.
Right.
K stands for the seed knowledge, right? So the perception should be guided by the goal, system's goal.
Right. Yeah, you make a big point of that in the book. Yes.
Okay, that is an important point. And then I will give you even more detail how to produce the comprehensive information, how to produce the perceptual information with the three components. As you can see from the model, object information, it is input to the model, okay? As the output of the sensing or sensor, you'll get the syntactic information. This is no problem, okay? And then you use either retrieval or calculation. You can produce the pragmatic information, the second one. And then combine syntactic information and pragmatic information, mapping both to the semantic space, right? And output.
What do you mean by naming there? What do you mean by naming?
Naming means we give a name to the output of semantic information. Give a name.
So just a plain name, any old label.
Just to give a name, no more.
No more. Okay. So
Yes.
in effect, you're indexing the knowledge.
At this point, we have mapping right. X and Z into Y, and then give a name to the Y.
Yeah. What is Z again? What is Z?
Z is pragmatic information.
The what information? Semantic or pragmatic? Ah, yeah, pragmatic. Okay, pragmatic. And what again do you mean by pragmatic information? Because I think I use pragmatic in a different way than you do.
Similarly, I think, because pragmatic information means whether the object is useful for reaching the goal or harmful for reaching the goal. Right. Yes, this is expressed by the pragmatic information. So, so the goal is something similar to the term you use, the intention. Right. Yes. So, I think to this point, we have basic explanation about two conclusions. One is...
Can I ask a question?
Yes. Yes, please.
How do you then say that you have two cooperating agents, right? And you perceive agent, let's call him X, or let's call him John, perceives Mary, okay? Using English names. I should use Chinese names, but I don't know any, but
okay.
How do you apply your theory to cooperative behavior between agents?
Can you see the new model, new page?
Yeah, I see this. Yes.
Yes. This is a model for the artificial social intelligence. I think.
Very good.
Yeah. We have agent number 1, agent number 2, and so on, and number n.
Right.
They work together, right? Perhaps one of the agents will play the function of the coordinator.
Mm-hmm.
Or
can, yeah. Mm-hmm.
Yeah. So as you can see, each agent will have two input and two outputs, right? One input is let me see.
Yeah. It's one way of looking at it. Yes.
Yes. For example, we look at the GAI, means artificial intelligence, general artificial intelligence. Number 2, it will receive the it will give a request to number n, okay, and it will receive the reply from number n, okay.
Yes.
The request will ask number 2 to do something, to take some action.
Sure.
Right. Yeah. And in this case, the number 2 will to make judgment whether the action is useful for reach the goal, the common goal, and his own goal.
Mm-hmm.
If it's useful, number two, they will perform the function of taking action. Otherwise, it will refused. So each of the agents will have sending out his own request and receive the reply.
Yeah.
Right.
Yeah.
In this way, they can communicate to each other and they can understand to each other.
Yeah.
Right.
Yeah. Yeah. I would say that is one particular way of having an interaction protocol between agents. There would be many different kinds that go beyond that. But okay, so are you done with your first presentation? Should we open it up for discussion?
Yes, please.
Yeah. So I see.
So do you use your PPT? In this, shall I end my PPT presentation?
Pardon?
I will get from the PPT presentation.
Okay.
Right.
Good.
You can
I
use
can see you. Good.
Yes. Okay.
Okay. Good. And I will turn on my camera.
Yes.
Okay. Good. You see me?
Yes. Very clearly.
Okay. Good.
Very good view.
Yeah. Yeah. So should I start my presentation or to try to link?
Yes.
Yeah.
Yes, please.
Yeah.
Please.
I will just talk without a presentation.
Okay.
Basically, under my view, to relate what you're saying with what I'm saying, is that, for one thing, I also have this notion of syntax, but you use it in a different way because I was more interested in communication, right? So I had multi-agents communicating with one another, and they had a language with a syntax. That language was interpreted by a semantics and the pragmatics. There was this difference between the information state of the agent, which is kind of the von Neumann view of a set of possible states that are consistent with the agent's knowledge. Okay, so it's a possibility view of information.
Sorry, can I say a few words?
Yeah, but let me just continue the overall. Okay.
Okay. Good.
The reason what I then is I generalize von Neumann by including uncertainty about strategies, because von Neumann didn't include that in his theory. So I generalized von Neumann's game theory to include strategies, so you can represent the intentions of each player in the game, or more generally agents. So then you can build up a theory of communication, not just about information, namely what's true or false about the world, but also about goals and strategies and agent actions, agent intentions. So that allowed me to develop a theory of agent intentions. And what was interesting then is that agent abilities, since abilities I define abilities in terms of an agent having a strategy to do something. Agent has the ability if there exists a strategy. What's interesting is that if you don't have the information, then the strategy does not exist. A blind man can't do things a man that can see can do. And so I showed a formal logic of ability based on information states, so that it formalized, connected information with ability and with intention. So information generates abilities, and abilities generate possible intentions. Okay, so they're all linked together. It's a unified theory of information, intention, and ability. And then you can combine that with communication theory, and then you can represent a whole social process of agents. Like your particular example would be an instance of the more general theory of protocols between agents interacting in a world with certain possibilities, with certain capabilities, with information, and with knowledge about their intentions. So you develop a whole theory of a combination of many different factors. And that, I think, that kind of theory can be the basis of an artificial social intelligence, where you then, if you have those components, what I call the architecture of the social mind, would have information states about the world, strategic states, but also what you point out as so important, also the goals and the utility, because the utility drives the formation of the strategies, as you correctly say. That's why your work is so closely linked with what I say, because we both are circling around similar ideas, namely intention, namely information states about the world, namely abilities, and communication systems. So, right? And so under my theory, I unify them, and you have a different way, but also unify. So it's interesting to see the relationship between what you're saying and what I'm saying. What I call pragmatics, what had to do more with the pragmatic interpretation is our operators that operate on the representational states of agents. These agents that have a architecture of the social mind, namely information, intention, utility, and then these high-level operators, much like quantum mechanical operators. That influenced me, by the way. I was influenced by the quantum mechanical notion of operator. And so these operators act on the mental states of the agents, transforming them, much like you talk about transformation states in perception, to guided by goals, to strategies, to action. For me, the thing was the interaction between agents to interact, to guide and create their strategies and coordinate their strategies to achieve something.
Yes.
Does that make sense, or did I talk too fast?
Okay. Yes.
Did I talk too fast?
I grasp the main idea. I have some comments.
Sometimes, because we're a different language, sometimes I have to talk more slowly. That's okay.
I see. I have the following consideration. Number one, artificial social intelligence is important. Because very important.
Oh, yes, yes.
Yes. Even more important than the other kind of AI.
Yeah.
Because human beings want to use AI to work with them together. Yeah. So there should be artificial social intelligence.
Yeah.
That's number one, my understanding. And number two, what I said, the paradigm revolution in AI will be able to support artificial social intelligence because the following reasons. Whenever an agent sending out a language, and then, may I say GAI, okay? GAI will be able to transfer or to convert the language that is syntactic information, convert it into perceptual information, including syntactic, perceptual.
Yeah, that too. Yeah.
Yeah.
But also into intentional information, because because of the architecture of the social brain, you have both. On the one hand, you have the information states, you have the strategic states, and the utility states, and they're all transformed by these, basically what you call conversions, I call operators on representational states.
Okay.
And so that's where actually we're using slightly different vocabulary, but you're doing basically something that actually Kant worked on, the philosopher, the German philosopher, where he was trying to understand how perception and the mind are related. And he presupposed that they have a certain innate structure to be able to even have the capacity to be in the world and understand the world. But we're going beyond Kant in the sense that we're actually looking at the social process. Now, it may have been that he wrote about that in other books I haven't read, But yeah, we're trying to understand the social process and how to build an agent that has this social capacity.
Yes.
And you're quite rightly saying, one of the crucial things, I think, is that the very notion of perception is already based on the goals of the agent. The very world
yes.
we live in is certainly looks differently to an agent with different goals.
Yes.
Like, for example, a man who's thirsty may only see your cup and he won't see that you have a gold ring. A thief may see your gold ring but not see the cup.
Yeah. Yes.
Right? So the perception of your goals are highly important. Yes.
Yes. Yes. Because the agent will have the goal, so no matter what kind of syntactic information the agent received, it will be able to convert it into the perceptual information, including syntactic, pragmatic, and semantic. And according to the pragmatic information, it can understand whether your order or your intention is helpful or useful for implementing the goal.
Right.
If it is, and then it will perform the function. Otherwise, it will say no, refuse it. So the agent will be able to understand what you said to him. Right.
Yeah.
This is the understanding ability.
Yeah. Where I try to, I know we're both talking at a relatively high level of abstraction. To actually implement this in a functioning model is yet another step, but it's important to have the right architecture in the implementation, right? So if we're going to implement this social ability of agents, we have to have the right architecture to begin with. And I think that's when you talk about the paradigm shift, you're basically talking about a different kind of architecture that has to be in the social mind and the artificial intelligence social mind.
Okay, yes. So, but may I say a few words about large language model?
Yes.
The large language model based on the neural networks and adopt a great number of new techniques, right? The purpose of adopting the techniques is to call back the semantic information and the pragmatic information, because the element or the prompt are used to call back the pragmatic information. They ignored pragmatic information before and ignored semantic information before. And then within the model of larger language model, they try very hard to call back the semantic information, call back the pragmatic information. So
how do you explain the success of something like ChatGPT or DeepSeek? I mean,
because they take a number of technical measures.
Yes.
Partially call back semantic information, partially pragmatic information. So this provides the possibility for them to perform the function looks like very well. But
definitely looks good.
It looks good. But the critical problem is they depend on the probability to produce the result. Okay, the probability,
like you mentioned in your book, these vector spaces, the
Yes.
the
The probability has nothing to do with the content,
right,
with
right.
the goal,
Yeah,
with
exactly.
the intention.
Yeah.
So,
The problem, as you correctly say, there's a problem with the notion of what understanding is. There's no real
yes,
theory of understanding.
yeah,
Uh, but what do you think of the proposal by some now that if we take multimodal models and train them on video, etc., and train robots in the context of action and vision, that they then automatically will be able to have a realistic semantics that associates language with operators on this social mind. In other words, we have two robots. The robot begins to represent the other robot, its
yes,
actions, its intentions.
yes.
Then we will be getting closer to a more general theory of social intelligence. Or am I wrong?
You're right. They need to build up the perception model
Yeah,
within their models, because perception can get the syntactic information, pragmatic information, and the semantic information.
yeah,
If they use precedent model, in my PPT, okay, not sensing, not only sensing,
right, right.
but sensing plus pragmatic information growing or producing, and the
Yeah,
semantic information producing. So the syntactic information come in, and then syntactic, semantic, pragmatic information come out.
yeah.
This is what they don't have.
But what I'm saying is, do you think they will have it if they start training robots with video, with actually interacting with other robots and learning from the interaction? So that in effect, they learn strategies by trial and error and then train the model based on the data that the robots and their interactions have, and with humans. I mean, much like a baby learns to interact, or is there a fundamental architecture that's missing in these models, like DeepSeek or ChatGPT? Uh,
Yeah.
I mean, one of the things, like, what they call large action models. You think large action models will get around this hurdle of understanding the pragmatics?
Action model is some called serving to convert the information into action.
Yes.
This is a kind of serving system.
A kind
You
of
have
what system?
serving,
Selling,
serving,
serving.
serving.
Ah, yeah, yes, serving.
Yes,
Yes.
serving system
But in a way you
means
can view it, but let me just in a way you can view it as a gradual buildup of a strategy system for an agent,
oh
where, they're given enough action training, conditional action training, you're gradually,
yeah,
incrementally building up a strategy. Once you have these different types of strategies in different contexts, you in effect have built up a huge bank of intentional possibilities where the agents can have intentions because they then activate a particular strategy that they've learned in the context of the learning system. So, I mean, potentially it's possible, I think, to build up the social agent by training it on action, on interaction,
yeah.
on with humans, with robots, with video, etc. So I think that's probably the way to go. The only problem I think right now is what I call the reasoning energy hurdle. Right now, the way these chats are designed, to do inference, they have to go start way from the start, repeat the whole darn thing all the way to the end. Whereas human brains are much more efficient. They're modular,
Yes,
highly
yes.
modular. I think the next step will be then to actually construct a modular intelligence
Yeah,
that has these
yes,
different pragmatic, semantic, syntactic capacities, just like we have.
Yes.
You know, we have the occipital,
Yes.
the cortex, the occipital cortex. We have the reasoning module. We have the
Yeah.
auditory. We have the Wernicke, which interprets and understands meaning. We have the Broca area, which generates speech.
Yes. Yeah.
And so we have the cerebellum, which is the fundamental action part that allows me to move my hands, right? But guided
Yes.
by the intentional structures. So I
Yes.
think the next step will be to actually develop a modular social brain, right?
Yes.
With appropriate training, perhaps we can do it. I have a different view. I'm publishing a paper on cracking the genomic code using AI, so that once we've cracked the code, in other words, we understand the genome, then we can in silico grow the brain on the way that Mother Nature grows the brain. So we will have the modular structure, the architecture of the human brain, but in silico. Okay.
Right.
So
Right.
I think it's futuristic, but I think it's doable. It's a huge project, yes, but I think it's a possibility. And then we will no longer have the what I call, you know, the inference or reasoning energy barrier, which right now is, if you have enough of these, you need an entire atomic power plant, a nuclear power plant to run the ChatGPT. It's crazy.
Yes.
Or if we have one mind here locally, we can out reason all these chats.
That's true. Yes.
Yeah.
Talking about the training, we also need training.
Yes.
But the training is not the same as what in the GPT.
No.
Not that kind of training, but in building up the knowledge base or information base, or use my term, memory base. Okay, during the building up the base, we need training, and we need inference or reasoning. Yes, because we consider the relationship between the cause and effect. So we use inference or reasoning to produce a strategy. All the strategy.
It may turn out that reasoning is not that hard of a problem. If we figure out the module for reasoning, it may be surprisingly simple, because, you know, if you look at, some people are born smart, other people are not born smart. It's some structure in the brain that may not be all that complicated. I mean, you know, you take a child who is naturally gifted from birth. They're just amazing, the differences in human beings. We're not, socially, we're not supposed to say that. Everybody's supposed to be the same, but it's obviously that people are not the same. If we can figure out how these modules work, these independent modules, and modularize them, then we will get rid of the reasoning energy barrier and be able to actually have reasoning machines that can fit on the laptop and outperform all the ChatGPTs.
Yes. So maybe the next time we will talk about the module.
The modular brain, the modular social brain.
Yes.
Yeah.
So to my impression that through the discussion between you and me, many common understanding has been reached. This is a very good result, I think.
Yeah.
And one thing I think many people don't accept. One is formalization, the methodology of formalization.
Formalization. Yeah,
formalization is not allowed to use in AI research.
What?
Formalization is not good methodology for AI.
Are you saying that?
Because formalization will be lose the semantic information. and pragmatic information.
Yeah.
Only syntactic information remain.
Oh, I don't agree with that, because you yourself use formalization in your book. I mean, by the way, I think we understand formalization differently. The way I see formalization is like abstract, like Newton did. Newton, Einstein, all the great scientists always used abstraction and formalization. There's nothing wrong with formalization.
Yes, you are right. All natural sciences, till the moment, can use the formalization. Not can use, but have to use formalization. Because natural science, of course, mainly in the physical sciences, they are interested in the structure of the entity, right?
Yes.
The structure of the entity should be described or expressed by the formalization.
Right.
But information cannot good enough express the information. I mean, formalization is unable to express information.
Yeah, okay, in that sense. But on the other hand, let me just say, on the other hand, if we say we want to build a modular brain, right, a modular social brain, then it would be good to have a formalization of the interaction between the parts, to have an idea of how to actually construct and build it. So in that sense, formalization can still come in to give a higher level view of AI models.
Right. In different part of
it's a different part. It's once you already have understood. Yes. I think you're talking about the syntactic level.
Yes.
What you call syntactic level.
Syntactic level is not enough.
Exactly.
Not
I totally agree with you.
AI. Yes.
I fully agree with you. Yes, there.
Yes, okay. So this is one. And another one is divide and conquer. Is also not good method for AI research. Mm-hmm. Do you agree?
I don't understand what you mean by it. So I can't agree until I understand you.
Because divide and conquer require you to divide the subject, the research subject, into different pieces.
Yeah.
And then you will lose information related to different parts of the subject.
But yes. Maybe I can respond to that.
Yeah. Yes.
Okay, like look at the brain. We divide the Broca area, the Wernicke area, the occipital lobe, the cerebellum, the frontal lobe. They're all different parts of the brain. We can divide them, but obviously you're right. The white matter of the brain, which is the crucial part of the brain. The crucial part of the brain is the white matter.
Yeah.
We can't, if we cut it, then you know the famous experiments by Geschwind, what you call connection syndromes, of people who had their corpus callosum, say, cut, or at birth was cut, or all these different syndromes you get if the white matter is cut. So I agree with you, divide and conquer by itself won't work, but for abstraction to work, right, you have some kind of divide and conquer, but then you reconnect them to understand it. If you do the Geschwind experiment and just divide and conquer, then you lose the mind. The mind no longer works. Yes. In that sense, I agree with you. You can't use divide and conquer only. But I think for conceptual clarity, it might be good to have a division of focus, which then, all the while realizing that these things are connected. And in fact, you get severe pathologies if you disconnect the brain. Right. So we can have divide and conquer at one level, but not fully. Obviously, you're right that divide and conquer, if you just chop things up, you lose everything.
Yes. I have a story.
Yeah.
Some time ago, a number of doctors wanted to understand the secret of the brain, how human beings thinking over a problem. They want to make clear the secret. So they just using cut the brain into different pieces and see the structure of each piece, and then after understanding the structure, and then they put them together. They want to know what the secret of thinking is, but result is they fail.
Yeah, sure.
Yeah.
Yeah, but if you look at, are you familiar with Geschwind? Geschwind. He's a famous, he's no longer living, but he's a famous scientist, neuroscientist who did studied these disconnection syndromes. In other words, human beings who have certain parts of their brain are disconnected, where the white matter is disconnected. Before that, people had no idea. They thought everything, they had no idea that the white matter was even important, or even know what it was, I guess. But yeah, so to understand the brain, I mean, if you look at the brain, the massive part of the brain is all white matter. In other words, he's connecting.
That's
all
right.
Connections. Between the Broca area is connected, and the Wernicke area is connected to the visual cortex by connections, and somehow the visual information is processed in the Wernicke area to understand the visual system, exactly like you say. The steps that you say in your work are actually modeled physically in the brain, right? So the visual information first passes from the eyes all the way back to the visual cortex. Then it passes to the front, to the Wernicke area. Once it's understood, then it passes to the Broca area, which then emits language.
Right.
So what you say is really also in the very architecture of the brain.
Yeah. That's a problem.
Yeah.
That's a big problem.
Yeah. But I think we can solve it.
You can solve.
I think we can solve it. Maybe not you and I, but somebody will, because using our theory, they will solve it.
Theoretically, there's a possibility.
Yeah, definitely.
But practically, there's very difficult, I think.
Yeah. But it may be, you know how these things go. What looks to be difficult suddenly becomes easier once we make a certain kind of breakthrough.
That's right.
So
that's right. I agree.
Look at DeepSeek. I was going to ask you about DeepSeek. What's going on? So how are they able to do this magic all at once?
Well, they do all the optimization. Toward the algorithm, and they improve the fashion of training. And so on.
Yeah. Tell them to do this, to try to solve the inference energy barrier, what I call the inference energy barrier, the IEB, where in effect, or the reasoning energy barrier, because it has to pass through all these neurons every time, every step. And if they can solve that, they will be of a huge impact on how AI can be made efficient and run on a local laptop.
I don't think they have solved the problem.
No, I don't think so. Of course not.
No.
But I'm saying, if you have contact with them, tell your students to start thinking.
I'll try. I will try. Yes. Okay. Actually, DeepSeek is basically the same as the GPT.
Yeah. Similar. Yeah, exactly. This architecture is similar. It just runs more efficiently, but still inefficient. If to really solve the problem with energy, we have to change the architecture to be more modeled on the modular brain, the human brain.
Efficiency is a very important contribution.
Yeah.
Of course, yes. So it's meaningful.
Yeah, exactly.
Okay.
And I think, and we have
Eric. Yes. There has been 9:36 in Beijing time. The
Yes.
tension work will be closed very soon.
Thank you for
So
your discussion.
thank you very much.
You are
We may have opportunity to have discussion next time.
good. Good.
Right. Okay.
Okay.
Thank
And
you.
thank you to whoever else is listening. And thank you.
Okay.
It was
Thank you very much.
read your book. I read part of the book. It's a great book. So
I have received.
yes, I hope you
Very
can
good.
correct the formulas and you can publish it in English. Very good.
Good. Thank you. I
Okay.
will read it very carefully. Right.
Okay.
Thank you.
Thank you.
So, should I say bye-bye for now?
Okay. Bye-bye.
Yes.
Bye-bye.
Bye-bye. Okay. Good.
Now, we'll stop the meeting.
Yes. Let's font.